Hi everyone, so today we'll be discussing about some deeper knowledges on functions, and I'm Luis Lu. And this video is created for my personal project, so if you feel this is useful, please fill out the Google Forms I will be sending out later on Gmails to provide me with some useful feedbacks and knowledges. Thank you. So for today, we'll be applying derivatives into problem solving. Derivative is a tool we use to find out the changing rate of the function at a certain point on the plane. And this can be shown through the dy over dx, which is similar to delta y over delta x, and which is y1 minus 1, 2 divided by x1 minus x2. And we used derivative to find out every global maximum and minimal points, but also the relative minimal and maximal points, as they all having the change rate 0 at those points. So if we finding the derivative of them, we will get 0. And graphically, the points were just the points here and here, and where their changing rate is 0, but also the global minimum points as down here. And here's some example questions. And please find out all relative global and maximum and minimal points of the following functions. And if you want to solve them, I will leave some time for you to do them. Okay, so let's do the first question out together. So for this question, we're finding out the dy over dx of them, which is 6x. And if you let 6x equal to 0, and the x will also equals to 0, and if we plug the x equal to 0 to the original functions, we will get the y equals to 6. As we all know from the section 1 that the function is a quadratic function, which means there is no relative minimum points. There's only the global maximum or minimum points, and we check the points here, 3. It's a positive number, so the function will be a concave up functions. So there will be exist one minimum points, and we believe that x equals to 0 and the points have x equals to 0 and y equals to 6. So the global minimum points for the first function is 0.6. And basically, the second question and the third question have the same method to solve them, so I won't do them all individually here. And if you have any questions, feel free to contact me to get more further help. And for the second question, please find out the global maximum or minimum points of the following functions. And if I will also leave some time for you to do them here. And you could pause the video here. Okay, I believe it's enough time for you to solve them, and I will do it here. So we're firstly finding out the dy over dx, the derivative of the original functions. We will get out the 12x squared and minus 6x and plus 1. If we let the function into 0, and all we have to do is finding out the solution of this quadratic equation. And to solve this, we firstly check the delta of the quadratic equation. We will get 36 minus 4 times 12 and times 1, which is obviously smaller than 0, and which means the delta, the solution do not exist. So there won't be any global maximum or minimum points of the function. Here are some real-life examples. Let the V be the volume of the cylinder, and R be the radius of its base, H be the height, please calculate the minimum proportion of cylinders so that minimize the surface area. And if you want to do by yourself, you could block out the answers and you try to solve it by your own. And here are the answers that are done by myself. So we know the base equals 2. So the p in here means pi. Because computer cannot type pi by it all. And v equals to pi times r squared and times h. And we can find also the surface area, the equation for the surface area for the height, also for the height. We just substitute or everything to a side except h, and we plug in h to the surface area equation and finding the derivative of r by it. Then we could find the proportion of the r to h. Lastly, the integral in odd functions. The integral, by its graphic meaning, we all know the integral is trying to find out the shaded area for any equation, any functions it's trying to integral. And in the odd functions, it's symmetrical of the points 0, 0, and it's also obeying the law that negative f of x is equal to f of negative x. So which means it will all cancel out and left up with 0. And it's actually a very useful concept in finding out integral in much harder functions that the only thing you have to do is to notify that it's a odd function and you will get out it's a 0. And integral in the even function. So for even function, we know that it's symmetrical to y-axis, and so we do not have to calculate the half part of them. You could forget about the left side or the right hand side. So for instance, we just forget about the left hand side in this example, and we just calculate the shaded area on the right hand side, and we just times with 2, and we will get both sides. So it's much easier to if you use this way rather than just finding out the both sides. And last part of this section, the drawing out functions. To draw out the functions, which means that the function have to be very complex. It's not just a quadratic or linear. It might be 3 exponent or even 5 or 6 exponent. So here are some my examples. Please draw out function f of x equals to x as 3 as the exponent, and 2x as 2 exponents, and minus x and plus 7. So for step 1, we're just finding out the roots of the function. The x is equal to -3. And secondly, we're using the derivatives dy over dx, finding out every single turning point of the function. Lastly, as it having the highest exponent is 3 and it's an odd number, which means the graph is from negative y-axis to a positive y-axis, from negative infinity until the first turning point in -1.3, and keep decreasing until the second turning point. Furthermore, the intercept of the x-axis is only at x equals to -3 as shown below. So this is the answer for the first questions. And you could say it's from the negative infinity keep increasing until the first turning point you found out by derivatives, and it turned down, and until the second turning point it turned up again. Here are some more practices you could use by the derivatives to briefly draw out the functions with higher exponent. Okay, so that's all for today, and hope you already understand how to draw a function out or the integral on even and odd functions. If you have any further questions, please email me and I will provide you with some more details about these topics. And thank you so much.